Hello all! Today we're going to modify this GBS board. That's a scalar board that takes analog video from VGA or component inputs and scales it to VGA. So we're going to modify it and make it become a GBS control board. For that we're going to use this ESP board here. That's going to make the handling of the firmware interface with the scalar chip that's included in the board. We're also going to install this optional component that's a clock generator, as well as replace some resistances, some resistors, some capacitors, and install these tantalum capacitors to improve the filtering. We're also going to remove the pots and these two white connectors here and here. Doing this, we're going to convert this 15 scalar board that has a lot of noise and snow and doesn't support many input resolutions to something that's worth 10 times the value of this board with these input components. As for these tantalum capacitors, normally you will install SMD capacitors, but they were not disponible in my local shop, so this is what I have to go. So let's get started. Well, it turns out that on this version of the board, the capacitors that are to be replaced are, well, something like here, and another here for the resistor, and well, the ones I have are through hole and are too big for that purpose, so the only ones I will install are these ones. That should be, well, I have to look on the web page on which one they are, but I think this one should be easier to install, and if not, well, then let's try with installing that. This is an old version of the board, it's 4.0, and since that the problems are detected on the board 5.0, 5.1, so maybe this board is free from those problems. Also, the board says 2019, also the board that says going to fail is 2017, so who knows. But clearly I can install this kind of capacitors or this kind of resistor in the place of the surface mounted ones. So let's continue with it. now it's finished. I have already tested it and everything is working. And you may wonder why this mess of cables. So this mess of cables have a very good reason. The reason is this is the second GBS control board I modified. The first one, this one, I used shorter cables, and the tension from the cables just broke everything. Like here, the capacitor there is no more, as well as the pin on that chip is no more, and that pin from that chip, that leg is up, and yeah, in the end a disaster. So I ordered another board to make this video and decided to use these cables. So I have short cables put in the connectors, and then using these extensions to longer and flexible cables. This way I can move this one way or another, so I ensure that there is no interference for the Wi-Fi signal, and also I don't have the tension on the chips and on the things on the board. Also, instead of taking power from this capacitor here, from C48 or 43, okay, from that capacitor, like the wiki recommends, why this just join the voltage here. You can follow the red and black cables to here. So the clock generator is getting the voltage from the same place as the ESP board, and that's logical, and that way those surface mounted capacitors don't have the tension of the cables. I could not add those filtering, but right now I tried and it works. It doesn't have noise, so I don't think they may be needed. This is version 4.0 of the board. This is shorter than the other version I had before, that was 5.1. Don't know why they sent me later and all the revision of the board. Also, this board is from January 2019 and this board is from October 2019, and still is an older model of the board. But anyway, it works, and I will 3D print a case for it. The one I had for the other board doesn't work because the other board is slightly longer. So I will show you later how it looks once inside the 3D printed case. You will see that this mess of cable doesn't matter. As long as it works, yeah, the mess doesn't matter. Also, this is more expandable because there's no another expansion that you can add on OLED screen and a potentiometer, and this way easier to just plug to the voltage instead of having to unsolder or the cables from the board itself or solder to a capacitor. You just cut the flexible cable in the middle and patch it again, and so on. So let's see how it ends when inside that 3D printed case. Okay, here it is assembled inside this 3D printed case and is connected to this Dell Optiplex DOS machine as well as this OSSC, because the problem is the unit I have, it has VGA output, so I still need to convert it to HDMI. But the advantage is that instead of using the OSSC as a scaler, using the GBS control, I get a nice 720p image that I can capture, because otherwise the OSSC with the DOS resolution just outputs at 400p at 70 signal. That's not supported by any capture card I know. GBS control on the otherwise just takes the 400p at 70 signal and converts it to 720p at 60. That's then converted to HDMI by the open source scaler converter. That's not supported by any capture card. I will show you now an image of the quality of all this daisy chain of conversion, and it's not so bad. Latency is practically non-existent. At least I could not appreciate it while playing normally. So you can see the results are pretty good, more or less the same you will get using an LCD with integrated VGA support. But with this you can get HDMI that you can then put on a capture card. Now about the other supported formats that are RGB through the RCA connectors or component through the RCA connectors. Usually these come from consoles, and on console I think the OSSC has the upper edge because the resolutions used by console are fully supported by the OSSC. It generates a more cleaner signal for the capture cards than using all this daisy chaining. But as said, for DOS it doesn't work like that. I have to test with Macintosh, Atari and other computer outputs and see if the OSSC can generate a proper signal, or it still needs the GBS control to upscale it first. Also, I'm waiting for a GBS compatible board with direct HDMI output to arrive and do the same modification. That's for another video, and then we'll see if we get any improvement here. So this has been all for this video. Thank you for watching, and please don't forget to hit like and click subscribe, and if you want to be notified, also click on the little bell notification icon. If you want to see more of these videos and you want to contribute so I can keep working on open source software for the preservation of computing history as well as video games, you can go to my Patreon and become a patron. I will be very thankful if you do. See you in the next video. Bye!